This is the third and final video that I'm recording for Chapter 7, talking about absolute values. So we've already looked at what absolute values are and how to use them for graphs, and in this one we're going to look at how to use them for solving equations. So we're going to be looking at absolute value equations, which again, not shockingly, is an equation that has a variable inside of an absolute value. So if you've already watched the video on absolute value functions, you should know that absolute values kind of do weird things around negatives, and we have to consider multiple possibilities. And that was true with graphs, and it's also going to be true with equations. So we're going to need to split our absolute value into two cases. And those two cases are basically the same as the piecewise functions that we wrote when we were looking at graphs. So our first case, case 1, is what happens if the contents of the absolute value are positive. And so that, when we were dealing with our graphs, was the stuff that didn't get flipped. It had a positive value. When we did the absolute value, nothing changed, and so it stayed as was. So that's when the absolute value has a positive content, or we can throw a 0 in with that case as well. Case 2 is, not surprisingly, going to be what happens if whatever's in the absolute value is negative. So the contents of the absolute value are negative. So let's look at a pretty basic example. If we had something like, say, the absolute value of x equals 2, you can probably just look at that and figure out what the numbers are, right? Well, the absolute value of 2 is 2, and the absolute value of negative 2 is 2. So we've got two possible answers here. But let's see how we can actually get those properly. So if we're looking at case 1, first thing we need to do is establish sort of a domain for this. So case 1 happens when the contents of the absolute value, x, are greater than or equal to 0. So if the thing inside the absolute value is positive, then it's not going to change the thing inside the absolute value. It's just going to stay as is. So for case 1, and this is going to be true consistently, we can just get rid of the absolute value and then just solve. So we're not going to have to do anything strange. We're just going to be solving normally. So in this case, the absolute value of x is just going to be x, right? Because whatever is in there we're saying is bigger than 0, so the absolute value won't do anything. So if we have the absolute value of x equals 2, well, we're just going to get rid of the absolute value, which is going to leave us with just x equals 2, and hey, it's solved, it's done. For case 2, that happens when whatever is inside the absolute value, which in this case is x, is less than 0, is negative. So we've established when this happens, and now we've got to see what happens. So for case 2, just like we did with our piecewise functions in the last video, we're going to take whatever is inside the absolute value, and we're going to find the opposite by multiplying it by -1. So we're going to multiply the contents of the absolute value by -1 to get the opposite. And then we're going to solve from there. So the absolute value of x is now going to be -x. And this happens if x were a negative number. So if we put, say, -3 in there, just as an example, the absolute value of -3 is going to equal to +3. But if x was -3, this is essentially -3. So we're finding the opposite of what we had. So going back to our equation then, we have the absolute value of x equals 2, which tells us that -x equals 2. And then to solve that, we're just going to divide both sides by -1. So we get x equals -2. And so we've got our two solutions, which are that x equals 2 and x equals -2, which we kind of already knew going into things. Like when we were doing radical equations, we do have to check our answers here for reasons that I'll talk about in a bit. So just to be sure, we got to check. And we have the absolute value of 2 equals 2, which it definitely does. And the absolute value of -2 equals 2, which it also definitely does. So both of our solutions are good. We're happy. Looking at another one, let's say we wanted to solve the absolute value of x plus 2. And now we're going to equal, say, 3. So now there's actually stuff going on inside that absolute value. It's going to make it a little bit more complex. So remember, case 1 happens whenever what is inside the root, or the absolute value, is positive, so greater than or equal to 0. And so this happens if we solve this, if we subtract 2 on both sides. This happens when x is greater than or equal to -2. So if we go through and solve that now, so our original function, remember, was the absolute value of x plus 2 equals 3. Because it's case 1, we just get rid of the absolute value and just solve as is. So x plus 2 equals 3. And we subtract 2 on both sides. And so we get x equals 1. Great, so that's case 1. Then we do case 2. Remember, case 2 happens when whatever is inside the absolute value is less than 0. So I'm going to subtract 2 on both sides, and I'm going to get x is less than -2. Notice how those two things are basically the same, just one's greater than one's less. That's always going to be how it is, so you don't actually have to go through the solving process twice. Just use the same thing, just flip the sign. All right, and so for this case, when we get rid of that absolute value, remember we have to find the opposite. So instead of x plus 2, this is now going to be -x minus 2. And so we're going to go through and solve that. We're going to add 2 to both sides, which is going to get me -x equals 5. We're going to divide both sides by -1. And we're going to get x equals -5. We do a little bit of checking. So if we plug +1 in as an answer, we've got 1 plus 2 in an absolute value that equals to 3. And that would give us the absolute value of 3 equals 3, which it certainly does. If we check the other one, we've got -5 plus 2, which is the absolute value of -3. And that also definitely equals 3. So we're all good there. So let's continue this on and make it a little bit harder. So let's see if we've got a little bit more variables there to deal with. So the absolute value of 3x minus 6 equals 4x plus 1. So again, we're going to go through our options here. So case 1 is when 3x minus 6 is greater than or equal to 0. So we're going to add 6 on both sides, which tells me 3x is greater than or equal to 6. If we divide by 3, we get x is greater than or equal to 2. Okay, so now we're going to do our actual solving. So we had 3x minus 6 in an absolute value equals to 4x plus 1. For case 1, we just get rid of the absolute value, so 3x minus 6 equals 4x plus 1. Remember when you're solving equations where you've got x's on both sides, first check to make sure it's not quadratic. It isn't. There is the possibility of dealing with quadratics in this. We're not going to in this course, but it is something that happens. I'll talk about that a little bit more at the end of the video. So since it's not quadratic, we just want to move all the x terms to one side of the equation, and then all the non-x terms to the other side. For me, I'm going to move that 3x to the right because that's going to get me a positive, and it's just a little bit less to deal with later on. So I've got -6 equals x plus 1. And then I'm going to subtract 1 on both sides, which is going to get me -7 equals x. So there's my x value. X is -7. Then I'm going to do the same thing for case 2. So case 2 is when 3x minus 6 is less than 0. And I'm going to skip all that middle stuff because it's just going to work out the exact same way. And it's going to tell me that x is going to be less than 2. So for our solving, remember when we get rid of that absolute value, this is now going to become -3x plus 6 equals 4x plus 1. So the processes now are going to be slightly different. So I'm going to add 3x on both sides instead of subtracting it like I did last time, which can get me 7x plus 1. Then I'm going to subtract 1 on both sides, which is going to get me 5 equals 7x. And lastly, I'm going to divide by 7, which is going to get me, unfortunately, a fraction as an answer, which, happens. And x is 5/7. So now we've got to check both of these. So go through and check these yourself. Get a little bit of practice. Try the checking, and then come back and then see what happens. All right, so our check. If we plug -7 into this, we've got 3 times -7 minus 6 equals 4 times -7 plus 1. So remember, you're checking one answer at a time. You're not plugging -7 and 5/7 in at the same time. So 3 times -7 is -21. 4 times -7 is -28. So that gets me the absolute value of -27 on the left equals -27 on the right. But this is a bit of an issue because the absolute value of -27 is +27. And so what we're left with here is +27 equals -27, which we know it doesn't. So if you think back to chapters 5 and 6, you should get a sense of what's coming here. And what we find out is that x equals -7 is extraneous. It is not an actual solution to our absolute value equation. And there was actually something that should have tipped us off to this earlier. So if we go back and we look at our sort of domain for this case, we found that x had to be greater than or equal to 2. But, well, -7 does not fit that. So that's no good. And so we've got an extraneous solution here. If we look at our second solution, 5/7, that is smaller than 2. So that's a good sign at least. But we do still have to do the actual checking to make sure. So let's do this with our fraction, unfortunately, and see how it goes. So we've got the absolute value of 3 times 5/7 minus 6 equals 4 times 5/7 plus 1. So that's going to get me the absolute value of 15/7. And I know I'm going to have to get a common denominator, so I'm just going to do that now. So my common denominator here is going to be 7. And that 6 is going to become 42/7. On the right, I've got 20/7. And same idea, that 1, if I make a common denominator, is going to become 7/7. And so what I get here is on the left, we have -27/7. And on the right, we have +27/7. And so when we do that absolute value, we end up with 27/7 equals 27/7, which is great. And so our second solution here of x equals 5/7, that one's totally valid. It's a good answer. And that is the solution to our equation. All right, so we're going to do a couple more quick ones to wrap up, and then we're going to talk about something slightly different. So let's solve the absolute value of 6x minus 19 equals -2. So here's the thing. If you look closely at this one, you actually don't have to do any work to answer this question, because there's something about this that, if you think about it, should stand out. And it is this thing over here. So remember, we're dealing with absolute values. There is no way that an absolute value is ever going to equal to -2. So this equation, right from the get-go, is impossible. There's no way this is going to work. It has no solutions. Right? We just know that just based off of how things go. Let's try another one. So we've got -2x minus 3 inside of an absolute value equals x minus 4. This one's for you to give a shot to on your own. So pause the video, work through it, make sure you check your answers as need be, and then come back afterwards and see how things went. All right, so for case 1, we've got -2x minus 3 is greater than or equal to 0. We're going to add 3 on both sides, which is going to get me -2x is greater than or equal to 3. Then we're going to divide by -2. And so hopefully, when you're doing this yourself, you remembered that there's something that has to happen here. Since you're dividing both sides of an inequality by a negative, just like we did back in chapter 5, you need to flip this inequality. So this isn't going to be x is greater than -3/2. This is going to be x is less than or equal to -3/2. So that's going to be a really common mistake if you're not paying attention. So you gotta remember to flip. Case 2, going to be the same thing, of course, but the opposite. X is greater than -3/2. So if we do our solving now, for case 1, -2x minus 3 equals x minus 4. I'm going to add 2x to both sides to get those x's over to the right to make them all positive. So remember, when you have multiple x's, move them all onto one side, just like we did on the last one. And that's going to get me -3 equals 3x minus 4. I'm going to add 4 to both sides. And that's going to get me 1 equals 3x. And then I'm going to finish this off by dividing by 3, which gets me x equals 1/3. Then when I go to case 2, remember we're going to do the opposite of the absolute value, so 2x plus 3 equals x minus 4. Going to subtract x on both sides, which is going to get me x plus 3 equals -4. I'm going to subtract 3 on both sides, which is going to get me x equals -7. So we need to check our answers now, but we actually don't really need to check our answers if we're paying close attention. So if you look at your restrictions from case 1 and case 2, you might notice that in case 1, our x value was supposed to be bigger than -3/2. And in case 2, our x value was supposed to be bigger than -3/2. Sorry, I might have said bigger for case 1. Case 1 is definitely supposed to be less than -3/2. And so with that being the case, if we compare those, 1/3 is supposed to be less than or equal to -3/2, but 1/3 is not smaller than -3/2. So that answer, no good. We don't even have to properly check it if it doesn't fit our case. And same thing for case 2. -7 is supposed to be bigger than -3/2, but it's not. So that one also gets rejected without us having to even properly check it. And so because both of those failed, both of our solutions are extraneous. And we have no solution to this equation, which can happen, right? That's the thing. So I just want to cover a couple of other quick things. I'm not going to do any more questions or examples, but just to talk about how some other things might work. So we can solve these absolute value equations a slightly different way. So if I asked you to solve something like, say, for example, the absolute value of 2x plus 1 equals 3. We could absolutely go through our cases and solve, and this one wouldn't be too bad. But what we can also do is actually solve this by graphing. So if you split this into 2 halves, so one side of the equation, and you graphed both of those as just y equals the absolute value of 2x plus 1, and y equals the absolute value of 3, oh, not absolute value, sorry, just y equals 3, you'd end up with something that looks very roughly, right, very, very roughly, like this. Right, not looking at specifics, just something along those lines. And then the y equals 3 is going to look something like this, of course. So to solve our equation here, all we actually need to do is find the place where those two lines cross, and you'll get your answers. So let's take a look at that on Desmos. So we've got 2x plus 1, we've got y equals 3, and so we can see we've got a couple of solutions there and there. But if, like we did in a previous example, we made that y value negative instead, you can see once this gets low enough, this just never crosses. It's just not going to be a thing. And so this would have no solutions. Something we can also have in the one that we just did. So the one that we saw just now, where we had the absolute value of negative 2x minus 3 and x minus 4. And so we can see those two lines never cross. Something that we didn't get into in this video, but that can happen, is you might actually end up with cases where you have more than one absolute value. So if I turned that x minus 4 into an absolute value as well, we'll see, oh, okay, now all of a sudden it does have solutions. It's actually going to have two. So when you have multiple absolute values, you end up having way more cases because you have to consider, well, case 1 for the first one with case 1 for the second one, and then case 1 with the first one with case 2 for the second one, and so on and so on. So the number of cases to consider grows really, really quickly. What you might also run into is quadratics. So you see this one down here where I've got the absolute value of x minus 3 squared minus 4. So if we graph that, we've seen this before in the 7.2 video. And so if we have that equal to 5, like we do here, we can see, okay, this has a couple of solutions, right? There and there. And then as I change that y value and make it smaller and smaller, now it has 3 solutions. And then if I keep going, now it has 4 solutions. And then right down here at the x-axis, it has 2 again real quick, and then suddenly it has none. So again, quadratics are going to make things much more complicated just because that's what they love to do. But it's not something we're going to get into much in this course, so don't worry about it too much. Our focus really is just on those linear equations. And even then, we're just seeing these as sort of a quick preview for Pre-Calc 12. So that's it for Chapter 7. That's it for absolute values. If there's anything that you're struggling with, make sure you go back and take one more quick look. But otherwise, move ahead to the next chapter that you're working on.